Hi everyone. Today we're going to be talking about solving equations, which you've been working on for the past few days. But more than just solving equations, now we're going to be solving for a variable in an equation that has other variables. Okay, so you're going to have an equation that has multiple letters in it, and I'm going to tell you one of those letters to solve for. So we need to talk about what that means. So when I say I want you to solve for x, or solve for y, or solve for whatever letter, what that means is you want to isolate the variable that I'm telling you to. So it means you want to isolate x or isolate y. Now, isolate normally means get by itself, and that's what it means in. Okay, so isolate means you want to get the variable on one side and everything else on the other. So for example, if I gave you the equation 3x plus 2y equals 12. Just to give you an idea of what the answer to this would look like, if I asked you to solve for x, you would end up with x equals, let's see, that would be 4 minus 2/3 y. And if you have no idea how I got that, that's okay. I'm going to show you that part, but I wanted to give you a picture of what this is going to look like, what the questions are going to look like, and what the answers are going to look like. But notice that when I did this, here x was kind of buried in the problem, and then here I got x totally by itself. So really, the steps you're going to follow are exactly the same steps that we've been following for equation solving this whole time. Let's suppose I take these two equations, solve for x. Well, this here looks just like what we've been doing. Okay, you would know how to solve for x here. I'm very confident in that. Solving for x here, we're going to follow very similar steps. So let's look at the left side. And the last thing I would do is subtract 1. When I subtract that 1, I end up looking like this. 3x equals 24. So if you look over here, this y is attached with addition just like this 1 was attached with addition. So I'm going to do the same thing. I'm just going to y. Okay, and when I subtract y, the problem is over here when I subtracted 1, I was able to do 25 minus 1 and get 24. I can't really do z minus y. I can't put those two things together. So what I'm going to have to do is just write it as z minus y. Okay? Let's go back to the left side here. So when I'm at this point, the next thing I would do, hopefully you can see, is I would divide by 3. And when I divide by 3, 24 leaves me with 8. Again, I have a 3 attached to the x, just like it was attached to the x over here, and I need to get rid of it because I'm trying to get x by itself. So I'm going to divide both sides by 3. When I do that again, I can't really divide by 3 because the z and the y aren't numbers, but I can divide the whole quantity by 3. So I just say I'm going to take this whole thing and divide it by 3. So the answers aren't nearly as pretty, but it's the same process. You follow the same steps. So sort of the questions that I tell you to ask yourself when you're doing one of these problems are as follows. And I'm going to tell you, there's going to be a lot of these that you're going to feel like you need help on. You're going to raise your hand and you're going to say, Mrs. Derigno, come help me. And I will come help you. But all I'm going to do is ask you these 4 questions. And when I ask you these 4 questions, you're going to know exactly what to do. So if you can get good at asking yourself these questions, you won't need me as much. First, you ask yourself, what am I trying to isolate? Which letter is it that I'm trying to get by itself? And that is always given to you right in the problem. It'll say, solve for x, solve for y, solve for m, solve for whatever. That's what you're trying to isolate. So whatever you're trying to isolate, everything else that's on the same side as that letter needs to move. Okay, so I'm going to go back to that example I used at the beginning. If I have 2x plus 3y equals 12, I hope that was what I did before. The x is what I'm trying to isolate, so that means the 2 and the 3y both need to move. Okay? So how is it attached? I'm talking about the thing that needs to be moved. How is that attached? So the 2x plus 3y equals 12. The 3y was attached with addition. The 2 was attached with multiplication. So what operation? And then to move something, we always do the inverse operation. which we sort of talked about when we did equation solving. But how do you undo the operation? That's the inverse operation. So for example, if something is attached with addition, you subtract. If something is attached with subtraction, you add. And those things I think you already know. I think you're already pretty confident on those. Okay, so let's try a couple. So in this first example, I have d equals r times t, and it's telling me to solve for r. So that means r is what I want to isolate. So there's my first question. What do I want to isolate? I want to isolate r. So then I need to think about what needs to move. Well, the t needs to move. Okay? How is that t attached to the r? Well, it's attached with multiplication. So then I ask myself, how do I undo multiplication? That's with division. Okay, so I'm going to divide by t and divide by t. Here my t's are going to cancel out, and I'll end up with d divided by t is equal to r. And that's it. I'm done. Because the question wanted me to solve for r, and I have r by itself. Some of you may want to rewrite this. You just like it better if it starts with r, so you could write it as r equals d divided by t. That's fine too. Okay.
Students, please excuse this interruption.
So let's take a look at this next one, and I might zoom this in to give myself a little more writing space here. This one is telling me to solve for w. So the w is what I'm trying to isolate, which means that this 2L, which I can treat as sort of all one piece, and this 2 need to move. Well, the 2L is attached with addition, and the 2 is attached with multiplication. Remember, there's really like an imaginary multiplication in there. So now I need to say, how do I move those things? And remember that when you're solving an equation, you go through order of operations backwards because you're undoing everything. So the first thing I'm going to get rid of is this addition here. So I'm going to do that by subtracting 2L from each side. And this left side is not as pretty as maybe we would like it to be, but it's going to look like this. P minus 2L equals 2W. Keep your eye on the prize here. We're trying to get W by itself. Don't lose track of what we're trying to find. If I want to get W by itself, to get rid of that 2, I'm going to divide by 2. So now I would divide by 2, divide this whole thing by 2, and I would actually be okay with you leaving your answer like this. Some of you may want to cancel out these 2's. What you have to be careful of is both of these things are being divided by 2. So you can cancel out these 2's, but this P will still have a 2 underneath it. So again, I would be okay with you leaving your answer like this, or if you wanted to write it not as one giant fraction, the P would still be divided by 2, but then you would be minusing, did I just say minusing? You would be subtracting just an L, because you can cancel those 2's out there. Just remember that the P keeps the 2 underneath it. Okay, so that's how you would solve for W. Let's try some trickier ones. Okay, so number 3, that's the formula for volume of a cone, and it's telling me to solve for H. So I'm trying to get the H by itself, which means the 1/3, the pi, and the r squared are all of the things that need to move. I always get rid of fractions first, and I've said this when we're equation solving a lot, because fractions are the scariest, ugliest thing out there. So let's get rid of that first. Let's think about how we could get rid of 1/3. What I would probably do with that is multiply by the reciprocal, which is 3. It's really 3 over 1, but that's the same thing as 3. So let's multiply by 3, multiply by 3, and so now this looks like this. 3v equals, this 3 and this 1/3 are gone, and then I still have pi r squared h. Okay, so again, I'm trying to get the h by itself, which means the pi and the r squared both need to go. And I'm gonna take a little shortcut here, because the pi and the r squared are both attached to the h with multiplication. So if they're both attached the same way, I can get rid of them all in one step. They're attached with multiplication, so I'm going to use division to get rid of them. So I'm going to divide by pi r squared, divide by pi r squared. This is gone now. And so for my final answer, I would have h equals this. H equals 3v over pi r squared. Okay, let's look at the second example here. This is actually the formula for area of a trapezoid. Not that you need to know that to be able to solve the problem, but just so you know. And this one is asking you to solve for h. So this is what we have our eyes on, which means we need to get rid of 1/2 and we need to get rid of this whole chunk here. And I said that way very specifically because we're going to treat this like all one piece. But before we worry about that, let's get rid of that ugly fraction, because like I said, that's sort of where I set my sights right off the bat, is I want to get rid of that fraction. And we can get rid of a fraction by multiplying by the reciprocal, just like we did before. So I'm going to take this whole thing and multiply it by 2, because 2 over 1 is the reciprocal of 1/2, and do the same thing with the a. So multiply by 2 here. That's going to leave me with 2a equals, those are going to cancel, and now I have h times b1 plus b2. Okay, and I'm trying to get the h by itself, which means now I need to get rid of b1 and b2. And those are attached to each other with addition, but this whole thing is attached to the h with multiplication. Okay, so this whole thing is being multiplied by the h, which means I can move that whole thing with the opposite of multiplication, or division. So I'm going to divide by b1 plus b2. And probably just to clear that up a little bit, I should put that in parentheses. I'm going to divide this by b1 plus b2. So when there's a whole parenthesis that's being multiplied by something and you're trying to get rid of that whole parenthesis, you can do it with division. And that's going to cancel out this whole thing. So now for my final answer for h, I get h equals 2a over b1 plus b2. Okay? So that's how I would solve for h there. Now what I want you to notice is number 5 is actually the exact same original formula as number 4. But this time you're being asked to solve for base 1. You're being asked to solve for b1. So this is going to take a different approach. All right, we're going to be doing something different because we've got our eyes on something different. I am still going to start the same way. I'm still going to start with that ugly fraction. Let's multiply by 2. Multiply by 2, because I didn't really need parentheses there. So I'm going to have 2a equals h times b1 plus b2. So this time we're specifically trying to dig out this b1, which means I'm not going to divide by the parentheses like I did before. I need to get rid of the h, and I'm left with just b1 plus b2. And since I just had the parentheses left over here, I don't need those parentheses separating it from everything else because I've gotten rid of everything else. So 2a over h equals b1 plus b2. Still have my eyes on that b1. So now I have to think about how to get rid of b2. Let's go back to our questions. What am I trying to get to? I'm trying to get to b1. So what needs to move? b2. How is b2 attached? With addition. So how am I going to get rid of it? With subtraction. So I'm going to subtract b2 over here. I know that's kind of hard to write in there, but what this is going to end up looking like is this. 2a over h, whoops. Try that again. 2a over h. And then I'm going to just put the minus b2 off to the side because I'm not mixing it in with the rest of the fraction. Stuff only gets to be part of the fraction if it's being multiplied or divided. And then this b2 is gone over here, so now that's equal to b1. Okay, so that was a much different process towards the end, solving for B1 than it was solving for H. And you'll see the answers come out looking quite different too. So you do have to pay attention to what you're being told to solve for. Okay, that's it for this lesson. Good luck and happy solving.